This is section 1.7, part C on formulas and geometry. A formula is an equation where the variables have meaning. So rather than just x and y that don't have any meaning attached to them, a formula is going to have meaning. So for example, if you saw something like A equals L times W, you would associate that with the meaning for length, width, multiply together to give you the area of a rectangle. If you saw the formula, for example, M equals y2 minus y1 over x2 minus x1, you would associate that with a meaning. This is the formula to find slope between two ordered pairs. If you saw something like E equals mc squared, that's a popular formula, you would recognize that to be Newton's law of energy. If you saw something like I equals P times R times T, you might recognize that as the formula for computing simple interest. Just a few examples of formulas. Okay, the first section we're going to look at some formulas that are geometric. In this first example, we're looking at perimeter and area of a rectangle. So we're going to first label this rectangle with its length and width. You can also label the bottom as length and the other side as width. And then we're going to talk about the formulas for perimeter and for area. So for perimeter is adding up all of the sides. So you're going to go around all four sides of this triangle, or sorry, rectangle. Got my shapes mixed up there. I'm going to go on all four sides of the rectangle. I'm going to go across the length twice and the width twice. So the formula is 2 length plus 2 width. And the area, like I already mentioned before, is length times width. Okay. So, example 5. A rectangular floor has an area of 192 square feet and a length of 16 feet. Find the width. I'm going to use the formula for area of a rectangle. 192 is the area, so that is equal to the length, which is 16, times the width. If I want to solve for the width, I need to divide both sides by 16. Okay, grab my calculator to figure out what 192 divided by 16 gives me 12. So the width is 12. I'm just going to restate that in units. So the width is 12 feet, since the units on this problem are feet. Okay. In example 6, a photographer plans to use 76 inches of wood to make a rectangular frame for a photo. If the frame is to be 4 inches wide, what will the length be? So since I know that a frame is going to go around the outside edges, that's perimeter. So the perimeter is going to be 76. That's going to be equal to 2 times the length, which I don't know, plus 2 times the width, which is 14. We're going to solve for the length. Okay. So 76 is equal to 2 times L plus, I know 2 times 14 is 28. I'm going to solve for length. I need to subtract 28 from both sides. Okay, so 76 minus 28 gives us 48 equals 2 times L. If I divide both sides by 2, that gives us 24. 48 divided by 2 is 24 for L. So the length is 24 inches. Let's look at the next page. The next page, we've got the perimeter and area of a triangle. So if I have a triangle, it has 3 sides. So perimeter, if you're going to go around it, you might label these sides A, B, and C. So the perimeter would just be A plus B plus C. If I wanted to find the area of a triangle, I need to know not just the side lengths, but I need to know the height and the base. The formula for the area of a triangle is 1/2 height times base, right? We usually write them in alphabetical order, so 1/2 base times height. Okay. So I'm going to find the perimeter and area of this triangle. So perimeter first. Perimeter is around the outside, so I'm going to add up the outside edges. So 1.7 plus 3 plus 2.7 equals 1.7 plus 3 plus 2.7 equals 7.4 inches. For the perimeter, and the area is 1/2 base times height. The base or bottom of this triangle, which is perpendicular to the height, is 3, and the height is 1.5. So 1/2, which I can just type as 1 divided by 2 for 1/2, times 3 times 1.5 gives us 2.25. And perimeter is measured in inches. Area is always measured in square units, so it'll be square inches. The inches are the unit. Perimeter has the same unit because it's a sum, but a product like area will have either square inches, square feet, square meters, etc. All right, so circumference and area of a circle. The formula for circumference of a circle, okay, it is 2 times pi times r. And the formula for area is pi times radius squared, pi r squared. Okay. In the circle in example 8, I don't have a radius. I need the radius to be able to compute each of these. What I have instead is the diameter. The radius is going to be halfway across the circle instead of all the way across. So the radius is going to be half of 2. So it's going to be 1. Okay, the diameter is 2, the radius is half of that. So if I want to compute the circumference, it's going to be 2 times pi times 1, which is the radius, which gives me 2 pi inches. Now this is the exact measurement. If you want to get the approximate measurement, you can use 3.14 or use your pi key. Okay, so 2 pi is approximately 6.28318, so 32 inches. Okay. Now it's important just to kind of keep track of these. The exact is 2 pi. The approximation is 2 times 2.14 or the pi key. And a lot of the homework, like my math lab, was going to ask you to enter both. It'll ask you to enter the exact, and once you hit enter on that, it'll give you a new box with the approximate. Just want to make sure you don't go right to the decimal. You need to enter the exact on many of the homework problems, so watch for that. Okay. And the area, that's pi times radius squared. The radius is 1. So 1 squared is 1, so the area is pi square inches exactly. And that's approximately 3.14. You could use your pi key if you wanted to expand that a little bit more. 3.14159 square inches. That would be the approximate area. Next page. The next page we're going to, there we go, use the formula. This formula has already been given for us. It's the formula for simple interest. And we're going to use the values a, p, and t and solve for the missing variable. So I have a, p, and t. I don't have r. It looks like I'm solving for r here. So a is 1025 equals p, which is 500, plus p, which is 500 again, times r, times t, which is 15. Okay, so I want to simplify this and solve. Okay, the first thing I might do is subtract the 500 from both sides. 1025 minus 500 is going to be 525 equals, and on the other side, while I'm simplifying, let's just go ahead and multiply the two coefficients of r. 500 times 15. 500 times 15 is 7,500. Gives me 7,500 r. Then divide both sides by 7,500 to get r. Okay, and I need to use my calculator for that one. So I take 525 divided by 7,500, and I get 0.07. 0.07 equals r, which means that r, which I know stands for interest rate. In this particular case, the interest rate is 7%. Oops, a little bit sloppy there, but there we go. Interest rate is 7%. All right, part B is the formula for the surface area of a rectangular box. I am given S at 72 equals 2 times, I know W is 2. Length I'm not told, so I'm going to be solving for length. Plus 2 times W is 2, times H is 3. Plus 2 times L, which I don't know, times H, which is 3. We're going to be solving for L. Okay, so I've got 72 equals, first of all, that's 4L. Plus 2 times 2 is 4, times 3 is 12. And 2 times 3 is 6L. Okay. So it looks like I have some like terms I can combine here. These are on the same side. So this will add up to 72 equals 10L plus 12. And then I can start solving by subtracting the 12 from both sides. 72 minus 12 is 60 equals 10L. And you could divide both sides by 10 to get L by itself. So 6 would be L. So LWH, L is for length, is 6. I don't have units up there, so 6 something, 6 inches, 6 feet, something like that. Okay. The next part, a little bit different, so we're away from the geometry part right here and talking about the total value formula. On the top of this example, there's a statement that 4 dimes are worth, I know that they are worth 4 times 10 cents or 40 cents. Okay, so we find the total value of the dimes by multiplying the value of 1 dime by the number of dimes. So this is just an example of that total value formula. You find the total value by multiplying the value times the number of objects. We're going to use this total value formula in the next example. Tickets for a concert cost $25 each. Find a formula for the total cost of any of these tickets. Okay. So the total cost T is going to be the value, which is 25, times N, which is the number of tickets. That's the total value formula in this example. Part B asks me to substitute 425 for T in the formula and solve for N, then interpret. Okay, so 425 replaces T, 25 equals 25 times N, divide both sides by 25, we're trying to solve for N. And let's see, 425 divided by 25 is 17. And when I interpret this, I want to make sure that I explain both the 17 equals N and the 425 equals T in my explanation. So 17 is N, that is the number of tickets, and 425 is T, that is the total cost. So if we buy 17 tickets, the total cost, not including taxes, but the total cost of the tickets will be $425. Okay. Next, example 11. Let A, B, and C be lengths of the sides of triangles, and let capital A be the length of an average side when you divide the lengths by 3. Okay, so the average side length, A, is going to be, you know that when you compute an average, you add everything up and divide by 3. So A plus B plus C, well, you divide by the number of things you have, which in this case is 3. So capital A in this case would be A plus B plus C divided by 3. Okay. So I'm going to use that formula in part B. So if the average side length is 19, that's capital A, and the length of 2 of the sides are 5 and 13, so say the first is 5 plus the second is 13, and the third I don't know, so I don't know C. I need to find the third side. So the first thing to do is combine like terms in the numerator. So if 19 equals 5 plus 3 is 18, plus C over 3. And then I know that if I have a fraction, I want to multiply both sides by the denominator to get rid of it. That's going to allow that to cancel. And it'll give me 3 times 19, which is, I believe, 57. Let's check that. 19 times 3 is 57. So that gives us 57 equals 18 plus C. And you can subtract 18 from both sides to solve for C. So 57 minus 18 is 39 equals C. So the third side is 39 inches. Okay, so in the next section, we're looking at a bunch of equations that are already written for us instead of having to write them, and we want to solve for a specific variable. So instead of plugging numbers in and getting a number as a result, we're going to get one of the variables by itself. Okay. So W equals F times D, that happens to be an equation for work, equals force times distance. I just want to solve for distance. That's force times distance. So if I divide both sides by force, I should have distance solved for. I can't simplify W divided by F, but that's okay. That's part of my answer. W divided by F equals, and dividing by force, so force cancels, equals distance. That's my goal, just to rearrange the equation to get D by itself. W divided by F equals D is my new equation. In part B, I want to solve for W. I'm trying to isolate W. If I want to solve for W, my first step is to subtract the 2L to get the W piece by itself. So we're going to subtract 2L from both sides. You can't do P minus 2L, so you just write P minus 2L equals 2W. And then to get W all the way by itself, you need to divide both sides by 2. You can't do P minus 2L divided by 2, so you can just leave it. Or you can't divide the entire thing by 2, but you could distribute the 2 division. You could divide both parts by 2, and then it would look like P divided by 2 minus 2L divided by 2 is just L. Either one of these is fine. They're both considered equally simplified. It doesn't matter to me which one you have. Just kind of showing you two different ways of getting equivalent expressions here. Two more. In part C, I want to solve for y. So I'm looking to solve for y, which means I want to get rid of x first. So I'm going to subtract 5x from both sides. Okay. It's going to leave you with negative 8y equals, and I could write 24 minus 5x. But I know that if I have just an x and a number, I want to put the x first. So I'm going to write this as negative 5x plus 24. And I'm going to divide both sides by negative 8. Okay. Now, up here, it really didn't matter if I simplified or if I didn't simplify, but this time, because I can kind of see ahead that the equation is going to be y equals, I really do want to simplify both parts so that I can see my slope and see my intercept. This one is the equation of a line. Okay, so I do want to divide them both by negative 8. I'm distributing that division, so both parts are divided by negative 8. For the first part, negative 5 divided by negative 8 doesn't simplify numerically, but the two negatives will make it positive. Positive 5 over 8x. And then a positive and a negative will make this negative, and 24 divided by 8 is 3. Okay, so that one I really do want to simplify because I can see now it's a line. I can see its slope and its intercept. Had I not simplified it, I wouldn't have been able to recognize any part of that line. So it doesn't matter when you're working with an equation that doesn't mean linear, doesn't mean slope, but if you are, you want to make sure you simplify the pieces. Part D, I want to solve this next equation for t, and since t is inside of these parentheses, the first step to do is to deal with those parentheses, maybe for example using the distributive property. So we'll go ahead and start there. So a equals p plus PRT. P times 1 is P, P times RT is PRT. And we're going to subtract the P from both sides. A minus B is just A minus P equals PRT. And then if I want T by itself, I want to divide by both P and R, their product. So A minus P over PR equals T. That is good. That is done. But you could also distribute the division if you wanted to, because the second one would simplify. You could write A over PR minus P over PR. The P's would reduce to give you 1 over R. Hopefully that page number doesn't bother you right there, kind of in the way of my writing. But I have A over PR minus 1 over R because P divided by P would give you 1 in that case. So either one is the same. You can leave it just like this if you want, or you could distribute your division. All right, this section continues on to the next page. And we're almost at the end. Example 13. The usage of natural gas vehicles in the United States was 8.3 million cubic feet in 1997, and it is increasing by 1.78 million cubic feet per year. Okay, so when I see this increasing by, that is a huge indicator of slope. When I say they're increasing or decreasing by a certain amount, I am being told the slope of this line. Okay, so I'm going to make a note of that so I can use that to write my equation. M is going to be a positive 1.78. Okay. Now we're working with, if you read out a little bit further, we're working with N being the variable for natural gas and working with T years since 1997. That's going to help me write the ordered pair for this one up here. The ordered pair since 1997 is going to be 0 for the year since 1997 itself is 0 years since 1997, comma my 8.3. Now it's particularly good that we have got 0 as your starting year because this gives you the b value for your line. It's a y-intercept. So anytime you have 0 with the x-coordinate, they're giving you the y-intercept. So the b value is 8.3. Therefore, the equation of the line would be y equals mx plus b. However, we're not going to be using the letters x and y. We know that we're going to be using t instead of x and n instead of y because those are the letters for the problem. T is the independent. Time is almost always independent of time as a variable. Time is independent, and the number of natural gas users is dependent. So my equation is going to be n, or if you want to make it a function, n of t, equals 1.78 t plus 8.3. Okay. Now, because I'm going to solve for a t, I'm going to rewrite this as an equation. Actually, the directions did say equation, not function, so I'm just going to call it n equals 1.78 t plus 8.3. Function notation is handy in some cases, but if I'm going to be solving for a different variable, it's all of a sudden not so handy because I got a little bit too many variables going on. I just want to solve for t in this equation. So I'm going to start with n equals, let me just rewrite that, 1.78 t plus 8.3. I want to solve for t, so I'm going to subtract the 8.3 from both sides. That should give me n minus 8.3 equals 1.78 t. And I need to divide both sides by 1.78 to solve for t. Now on the left-hand side, I have to distribute this division to get it in slope-intercept form. So I have n divided by 1.78. Keep in mind that there is currently just one n here, so I have to divide 1 by 1.78 to get the new coefficient of n. Okay, so 1 divided by 1.78 gives us 0.562. So we have 0.562n minus 8.3 divided by 1.78 gives me 4.663. Okay, so that would be my equation with t solved for. Oops. Part C, last part here, predict in which year the usage of natural gas for vehicles will be 31 million cubic feet. Okay. I could use either equation. I could use the top equation and plug 31 in for n, or I could use the equation I just found and plug 31 in for n. I will get the same result, but since I already have an equation that has t solved for, if I plug 31 here, I just need to multiply and subtract to get my answer. So the work has already been done in solving for that equation by finding that inverse. I'm going to take 0.562 times 31 minus 4.663, and that is equal to t. I just need to simplify. So 0.562 times 31 minus 4.663 gives us 12.759. 12.759 is equal to t. Now recall that that was a year value since 1997, so I need to add 1997 to that. 1997 plus 12.7 gives us 2009.759, or in the year 2009. So in summary, in 2009, the usage of natural gas was, and again, always talk about the value that you got out and the value that you plugged in, so it was 31 million cubic feet. And that is the end of this section.